factoring, the most important thing to remember is your multiplication facts. And the fact that you guys all fill this out incorrectly. Remember, when you're filling these things out, just a little warning here.
So you go like this.
Think about it going to the right,
And then
repeat it going
say
down.
what- that's what I
Think about
did
it, repeat
I
it.
did it.
Think about
I
it,
did
repeat it.
Look at, I was smart.
I know, air 5, way to go.
Oh,
Good job, it's air 5s. Now, what happens though when we're talking about factoring?
yeah.
When we're talking about factoring, I know that you guys have all seen this many different ways. The way that I always show factoring when my leading term coefficient is 1, my A value is 1. You guys can stop now because I don't need to worry about factoring, okay? All right. I'm always asking myself the question, what times what is negative 28 that adds together to get negative 12? So what are my factors of 28 that gives me a sum of negative 12? That's one method that most people have seen. I know that you guys grew up, you might have done the box method, you might have done something else, lattice, whatever. I think that this method, what happens here when I use this method, I think it's the most efficient way to set up and factor. It's an easier way to do it, especially if you know your multiplication facts. That's kind of why I always start these lessons out with the times table test. I am still unbeaten in all the years I've done this. I was done for 7, but that's okay. So what are 2 things you multiply together to get negative 28 and you add together to get negative 12? Remember, if you have 2 things that multiply to get a negative, it means you have to have 1 positive, 1 negative. And then if you have 2 things that add to a negative, the larger of the 2 should be negative.
It's negative 14 and 2.
Good. It's 2 times negative 14, or negative 14 times 2. Doesn't matter which way I write it.
It doesn't
Nope.
matter.
So when you're factoring, what you're doing is you're figuring out the terms. Well, x plus 2, x minus 14. That's what it looks like. Okay. I know you guys have all seen this. This is a reoccurring thing that you get in just about every single class. Yes?
What about the 12?
What about it? What's 2 plus negative 14? Remember, what I'm doing here is I'm factoring out to figure out what times what's negative 28, but I add together to get negative 12. So when you FOIL this back out, or Billy binomial, you don't know Billy binomial? I thought you would have at least known that.
Billy trinomial.
Ready? First, outside, inside, last. It's Billy binomial.
It's called foiling. I think he called it that.
What? What is that squiggly line? Is that
He's smirking.
There already is a face. You don't need another. I love your amount. You don't need another.
that was
You're much better at Jalen.
Thank you.
that's bad.
That was bad.
That one is. Oh, he skipped away.
What times what is negative 21? Remember, what I'm doing here is I'm trying to figure out what times what. What are the factors of negative 21 that gives me a sum of positive 4? So this is your multiply, and this is the add.
7 and negative 3 is right.
Something along those lines, yes. 7 and 3 gives me some sort of a combination. If I want the sum to wind up being positive, that means the larger of those 2 values should be positive. That's why I get the negative 3. So when I go to factor this out, my terms wind up being x plus 7, x minus 3. Let me ask you this. What changes if I do this? What am I asking you to do then?
You're trying to figure out 2 from the answer.
Yeah, I'm trying to find the zeros. That's what it's called, finding your zeros, solving. So think about what we did yesterday when we had intercept form. What are your zeros for this? Negative 7 and positive. Good. That's the second part of this lesson, really, when we start doing finding zeros. You're just taking it one step further and finding zeros of each one of those things in parentheses. Okay. Let's try another one. This is all skipping around here. Jeez, no violence.
He just doesn't remember anything.
Oh, shut up! Stop!
We've done this. This is
Well, and this is a jog of the memory. We're gonna do. I was gonna do all of factoring in one day, but then I realized, we'll slow it down.
I was like,
We'll do factoring over 2
I
days.
was like, Alex, you understand these parabolas? He's like, yeah, dude, we've already done this. No way. Yeah. It's like, whatever, Alex.
Yeah.
Oh, man, we've already done this.
What times what's positive 28 that you add together get negative 11?
Negative 7 and negative 4.
Very good. Negative 7, negative 4. Do we all agree? You all right?
Oh, yeah.
Okay. Okay. I was just making.
The only part I have a problem with is their parabolas.
All right. Well, stop it and flex. We'll get you through it. It's real easy. Remember, if you're multiplying together to get a positive, and your middle number is negative, that means they both have to be negative.
So if it was equal to 0, then it'd be 7 and 4.
Very good. Very good. If this said equal to 0, just like Hunter said, your zeros would be 7 and 4. What are your x-intercepts?
7 and 4.
What's your axis of symmetry?
7. 7 count 5 and a half.
Very good. 5.5.
Are you
Oh, that is bogus.
Yes, sir. I won't be here tomorrow. If you want to use one for money, by all means, help yourself.
Oh, I can't come Monday. Oh, tomorrow's Saturday.
Do you remember the little something called difference of squares?
No.
No.
No, there's no way.
Nope, that does not ring a bell.
We have x squared minus 1. Is there a b value here? No. So all you have is an a and a c.
Probably not.
Is the first term a perfect square? You know what that means?
Yes.
What does it mean?
S.
Perfect square means that there are two things that are the same thing that multiply to get x squared. Well, those two things would be both x.
Yeah. Okay.
Is 1 a perfect square?
Yeah.
Maybe.
Is that a subtraction symbol?
Yes.
Wait, but -1 isn't.
I'm not asking about that. I'm asking, is this a perfect square?
Yes.
Okay. Is that a perfect square?
Yes.
Is this a subtraction symbol?
Yes.
Did you answer yes to all 3 questions?
Yes.
Most likely.
That means your two terms are x minus 1, x plus 1. What happens here when you FOIL that out? The middle term goes away. When you FOIL that out, you get x squared minus x plus x minus 1. X squared minus 1. It's called a difference of squares. Anytime your first term is a perfect square and your last term is a perfect square, it falls in the pattern of square root of the first, square root of the last, plus minus. Richard?
So you did all of that work just to get the same answer.
No, what I'm doing here is I showed you why it worked. This is the check. This is the answer.
Oh.
Okay, Caleb?
Do you, does x equal whatever number?
Does x equal the number being squared? Is that what you're saying?
No, does x, like, if x squared minus 2 is the equation, would x equal
No, because it's 2 a perfect square. Then it can't do that
2?
pattern.
So
It only works.
X squared minus 4.
That'll work. That'll be x plus 2, x minus 2. What?
So you take the square of the number being added or subtracted.
Ah, it only has to be. It only can be a subtraction.
Okay.
So
you
this.
take the square root.
Yeah. If this is a perfect square, that's the only way this works. Dylan.
That was my question. If it could be.
Yeah. And this cannot be positive. Another reason why this works.
Why can't it be possible?
Well, I'll show you. If this was positive, and let's say I wanted to find a 0.
It would be
If I set that equal to 0, I'd have to move the negative, move it to over to the other side, right? So I have x squared equals -4. How do you undo squaring?
can't.
Well, square root. It can't be.
Can you take the square root of a negative number?
No.
Not until section 5.4.
Oh.
Yeah.
That's when you have imaginary.
We did that
Oh,
before.
square root of 4 times.
So this becomes x equals plus or minus 2.
Not a number.
Okay.
Because you can't get that.
Look up the math.
One last example before I let you go with some problems. Now, this is where we'll probably start off on Monday as far as how to work with leading term coefficients that are not equal to 1.
What do you even do?
Well, you don't cry. You start by writing down the problem.
I have one try afterwards.
Afterwards is okay. Here's the way that I always do these problems. I do these a little bit differently than the book does, than probably you've ever seen, but it does take about a minute or so longer to do, but it forces you into a nice, easy pattern. Here's what we do. I take the first term and the last term. What's 3 times 5?
15.
Okay. What times what is positive 15 that adds together to get negative 8? I need 2 numbers that multiply for a positive, but when I add them, I get a negative. That means my 2 numbers have to be negative 3, negative 5. Do you guys agree? All right. So here's what I'm doing. I'm splitting my middle term. I'm going to do factor by grouping. I rewrite this as 3x squared minus 3x minus 5x plus 5 is 0. What's negative 3 minus 5? It's negative 8. All I'm doing is I'm breaking apart that middle term. Okay? This is different than what you guys have probably ever seen. Now, what's the greatest common factor of 3x squared and 3x? 3x. If I factor out a 3x, I'm left with x minus 1.
I see that.
Okay? Now, what I want to do is create that second term to have the exact same chunk in parentheses. Here's what happens. What's 5 divided by negative 5? Negative 1. So if I factor out a negative 5, I'm left with x minus 1. Do you agree? Is that the same thing in both parts in parentheses, x minus 1?
So you can cancel.
I'm not canceling them out because I'm factoring this into 2 terms. So if these 2 are the same, write it down. This takes a little time to get used to. What's left? And that's how you factor it.
So you have canceled the first
What I'm doing here is factoring. I'm factoring by grouping. Now, in the other classes, I had a couple of extra minutes to get this far, to go into a little bit more of this. With you guys, we didn't get that far, which is not that big of a deal. We'll leave off at this part on Monday. What I want you to do over the weekend is in section 5.2.
Is that the answer, Mr. Murphy, though?
You have to set it equal to 0, but we'll leave that for later. I want you to do numbers 24 through 34 evens on section 5.2, page 260. But I want you to try 36 and 40. Give those a try. It's the leading term coefficient not equal to 1. Just try it. See if you can do it. We'll leave off at that. Okay?
You're literally so crazy.